Hello everyone, I am Rhett from Ri3D at Purdue, and I'll be talking with you right now about the electrical system of our robot, #Alicorn. A quick word of warning about this robot: a lot of electrical components were moved really last minute and are not in their current position, so I'll talk about them as if they were, but I will typically preface it by saying that right now, for example, this spark max isn't here, but there normally would be one for our swerve drive to work. So we're going to start with a quick mention of why you can see all of the electrical components with the robot tipped over on its side. This year we elected to use what is considered a brain pan, where we mount all of the electrical components on the bottom of the robot. We decided that this is fine and rather simple to do due to the lack of small game pieces and low chance that something could roll under the robot and cause it to get damaged. Another one pro of doing this, other than making it easy for you guys to see all of this, is that it moves all of the electrical components to a slightly more protected space and gives us more space on the top of the robot to do other things. So, with that note, we're going to start from where the battery runs into the robot, which is down here. It then runs up into the PDP. From this, we've got power that will branch out everywhere. Real quick, I'm going to mention that right up here is where it runs up into our Rio. We have this wire that runs over here to our VRM. From the VRM, we have power that runs over here to our Pigeon, which we use for our swerve drive, as well as power which runs up here and runs into our power for our radio. So down here, we have these 8 ports with 40 amp fuses. Those are the power for what would normally be our swerve drive. You'll notice that you see swerve drive, should have 8 motors, but there's only 5 spark maxes here. That was part of what I was talking about earlier. We had an issue where we could not put CAN IDs onto the spark maxes due to an issue we have not figured out yet. But that meant that in a frantic fix to try and get the mechanism working, we removed spark maxes from these 2 swerve pods in a hope to try and get the robot to barely function. So you'll see that we have power from this port up to this spark max. From this port, which normally would run up to this spark max, runs up through this little spot here and runs off to a spark max elsewhere on the mechanisms that I'll show once this robot is flipped back onto its wheels. We have power that runs from this port down here, which runs up to this spark max. This port goes down to that spark max. These 2 ports, which normally would run power to one of these 2 motors, and to the spark max, which then runs it to the motor, actually runs up here through this hole, as well as this port up here runs through the same hole. This power port runs up to this spark max, and this one runs up to this spark max. Now you'll see up here we have 4 fuses, 3 30 amps and a 20 amp. These were originally intended to be our mechanism fuses if we got everything wired up correctly and properly. So these 2 ports run up to a wire that runs up and back here, which runs to a spark max mounted right here. This was originally intended to be the winch motor for our climber. We have these 2 wires coming out from over here, which run to this spark max here. That was originally intended to be our 4-bar motor, although since we could not get CAN IDs to work for those 2 spark maxes are just sitting unconnected to anything. So now we're going to do a quick trace of all of the swerve drive CAN. So starting from the Robo Rio, which is where typically you would start when tracing CAN wire, we run out of the Robo Rio, down into this spark max here through this wire, out the spark max into here through this wire, and then over here up to the Pigeon, around and into the Pigeon here, which branches the gap from here to here. So then the Pigeon will run CAN out of the Pigeon, up, down, around, and into this spark max. Then we run CAN out of this spark max. Originally, this was intended to plug into the spark max that normally sits right here, but as I said earlier, it moved, so the CAN instead got connected to this spark max down here. This spark max then runs its CAN up to the one above it. Then that runs down into the PDP. Now, we have the terminating resistor turned off on our PDP, which allows us to then continue the CAN loop out from this side and up, over, and up to the rest of the robot mechanisms up through a hole over here. Another quick note while we have the robot flipped over like this, our Ethernet cord runs out of the Rio up here and over through a hole down here next to the swerve drive. Now, originally all of the CAN that was intended to run through this hole down here, which we cut to run power up for all the motors and mechanisms, either through these tubes or they were going to go through this hole. But as I mentioned earlier, we ran out of time and we're doing things very rapidly, frantically, sort of similar to a situation in the pits where you got 3 canners, you don't know what's working or something's not getting power quite properly. But that is all for this side of the robot. Now I'm going to tip it over and show you where all of the wires that are coming up here for the mechanisms go. All right, now we are going to talk about where all of the power for all of the rest of these motors comes out up here once we get to the top of the robot. So normally we would mount our battery somewhere probably around here. We did not have a lot of time to get that figured out because we were saving it to work on changing center of balance with the climber, but unfortunately we ran out of time. So we were going to put the breaker in a similar spot. Right now the breaker is sitting a little loose, which is not something you should do. It should be attached, but our breaker is back here next to the climber. So as I mentioned earlier, we have power wires coming up through here out of the, well, it'd be the right side of the Robo Rio with this being the robot front, that runs over to here and connects into this SparkMax here, which then powers the Neo here, which allows it to run this chain. This sim is not currently connected to anything because we could not put these SparkMaxes on brushless mode for them to run properly. So this sim is sitting unpowered, which is why we cannot do any sort of demonstrations or videos of the sim working in progress, working at all. Now over on this side of the robot, we have the power wires coming up from this hole right down here, as well as the CAN. So the CAN runs up through here, over and into this SparkMax here, which you can see with the orange duct tape. The CAN then runs up here, where it then runs through this parallel bar here, then comes out down here, runs up here, around through here to these 2 little ports, which we just had in pre-done wires. Then all the way up here to this SparkMax. Normally this would be plugged into the SparkMax here, which drives the Neo 550, and then it would run into the SparkMax here, which we have mounted down inside here, which then powers this Neo, and then it ends off with the terminating resistor like I was talking about earlier. For you to put the PDP on the terminator, to turn the terminating resistor setting, off on the PDP, you need to add one somewhere else, and that will end your CAN loop. This is where we elected to put ours, that way we wouldn't have to run CAN wire all the way back down as it went up the robot and in. And that is all of the most basic form of wiring you can get with this robot. The wiring is very hard to follow at times, which is why I messed up a couple times personally. And hopefully if we get this robot working better, we will clean it up a little bit and I'll re-record this video for you with a lot easier to follow and nicer looking wiring. As always, if you have any questions, feel free to leave them in the comments down below or on our Chief Delphi thread. And thank you for watching.